welcome to Maths class. Today we are studying about geometry and straight lines. Okay, today our topic is geometry. Okay, today we are studying about geometry and it's an important section is straight line. Okay, first of all I have a simple question. Who is usually known as the father of geometry? The father of geometry is Euclid. Euclid is known as the father of geometry. Okay, first we may study about geometry. Euclid is known as the father of geometry. Okay, now listen. Why Euclid is known as the father of geometry? I will explain it. Just listen. If there is only one point, then we can say that it is called zero dimension. When we connect two zero-dimensional objects, we get one dimension. Okay, that is a straight line. Okay, remember that if there is only one point, then it is called zero dimension. When we are connecting two zero dimensions, we get a straight line. It is called one dimension. When two one-dimensional figures are connecting, we get 2D, two-dimensional object. Okay, for example, that is a rectangle. When we are connecting two-dimensional objects, we get a 3D shape like this. It's a 3D shape, three-dimensional object. For example, cube, cuboid, etc. are three-dimensional objects. When we are connecting two three-dimensional objects, we get a fourth dimension. It will continue like this and finally we get n dimension. It is called n-dimensional Euclidean space. That is why Euclid is usually known as the father of geometry. Okay, got the idea? Remember that Euclid is known as the father of geometry. He introduced dimension and all other concepts. Okay, and now, but in the case of physics, the fourth dimension is, I will explain it, just listen. Okay, now listen. In the case of physics, x, y and z, the fourth dimension is time. In the case of physics, x, y and z, the fourth dimension is time. Fourth dimension. If you want to study more about it, you must read a book. It is written by Stephen Hawking. The name of the book is A Brief History of Time. It's a beautiful book. You must read it. You can get more ideas about dimensions. Okay. Now we can move to our concept, that is straight lines. Okay. What do you mean by a straight line and its standard form? Listen. Okay, straight lines. Our topic is straight lines. Straight lines. Listen. What is a straight line? Straight line is the shortest distance between 2 points. If 2 points are connected, then the shortest distance is a straight line. Okay, remember that the shortest distance between 2 points is usually referred to as a straight line. Okay, first we are studying about distance formula. Okay, what do you mean by distance formula? Listen. What is distance formula? Okay. If there is 2 points, first one is P. The point P is x1, y1 and Q is x2, y2. The 2 points are there. Then the distance D can be calculated by using the equation x2 minus x1 the whole square plus y2 minus y1. y2 minus y1 the whole square. It is called the distance formula. Okay, remember that we have to find out the distance between px1 y1 and qx2 y2. The distance formula is d equal to root of x2 minus x1 square plus y2 minus y1 square. It is called distance formula. Okay, now we can do a problem based on this distance formula. Listen. Find the distance between the 2 points. First one is 6 minus 4 and the second one is 3 0. Okay, 3 0. Find the distance between the 2 points. First P is 6 minus 4, Q is 3 0. Okay, we have to find out the distance between P and Q. How to find out? The distance between the 2 points 6 minus 4 and 3 0. How to do it? Remember that here this one is x1 y1 and here is x2 y2. Okay, x1 y1 and x2 y2. Then using distance formula d equal to root of x2 minus x1 square, that is 3 minus 6 the whole square plus next y2 minus y1, that is 0 minus of minus 4, that will become plus 0 plus 4 the whole square, that is equal to root of 3 minus 6 minus 3 square, that is 9 plus 4 square is 16. Therefore the answer is root 25, that is equal to plus or minus 5, but we may take d as plus 5 because it is distance. Okay, remember that the distance between the 2 points 6 minus 4 and 3 0 is plus 5. Plus 5 is our final answer. Remember that we are taking only the positive value because we are finding out the distance. Okay, what the idea? Now we can move to our next question. Listen, now we can move to next question. Okay, remember that who is known as the father of geometry? The father of geometry is Euclid. Okay, and Euclidean space is very important, and we are studying about straight line. First we may find out the distance formula. Remember that what is our distance formula? Distance formula is the distance between 2 points x1 y1 and x2 y2. The answer is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. That is our distance formula. Okay, now we can move to our next question. Okay, this is our distance formula. Okay, remember that the distance formula d equal to root of x2 minus x1 square plus y2 minus y1 the whole square. You may take the positive value. Okay, we are applying the distance formula to find the distance between 2 points. Okay, now we can move to our next section. Okay, our next section is, remember that if there is a straight line with angle theta, then here is the angle. Just listen. I will draw once more. Listen. Here is our x-axis, y-axis, and here is a straight line L. Here is a straight line L. L is the straight line. Here we may form two angles. The first one, this angle is theta, and the remaining, this angle will become 180 minus theta. Okay. What the idea? First one is x-axis and the second one is y-axis. Here the angle is theta and the remaining angle is 180 minus theta. Okay, remember that the angle of a semicircle is 180. That is why if here is theta, then here is 180 minus theta. Okay, now listen. If theta is the inclination of the line segment L, then tan theta is called the slope or gradient of the line L. What is slope? Slope equal to tan theta. Okay, remember that if theta is the inclination of the line segment L, then tan theta is called the slope or gradient of the line segment. Okay, slope is usually represented by the symbol m. M equal to tan theta. Okay, that is the slope of our equation. Slope. Okay, slope of a line segment whose inclination is 90 is not defined. Why? Tan 90 is not defined. Okay, remember that theta not equal to 90 degree. Okay, it is very important. Remember that in the case of a line segment L, if theta is the inclination of the line segment L, then remember that tan theta is called the slope or gradient. The slope or another name is gradient of the line segment L. Okay, the slope of the line L whose inclination is 90 degree is not defined. Okay, remember that m equal to tan theta. Remember that theta not equal to 90 degree. Okay, this is our figure. Okay, what the idea? Now we can move to our next section. Okay, next section is very important. Slope of a line when coordinates of any 2 points on the lines are given. Okay, how to find out slope of a line when the coordinates of any 2 points of the line segments are given. Listen, here is we can find out 2 points. First P. P is the point x1 y1 and another point is Q. Q is the point x2 y2. Okay, then what is tan theta? Then tan theta equal to y2 minus y1 divided by x2 minus x1. Okay, tan theta equal to y2 minus y1 divided by x2 minus x1. What is our tan theta? Tan theta is the slope. Therefore, this can be written as m equal to y2 minus y1 divided by x2 minus x1. Okay, remember that if 2 points are there, P and Q, the P is the point with the coordinates x1 y1 and Q is the point with the coordinate x2 y2. Then tan theta can be calculated by y2 minus y1 divided by x2 minus x1. Here tan theta can be written as m. M equal to y2 minus y1 divided by x2 minus x1. Okay, it's very important equation. You must study it. Okay, now we can move to our next section, that is based on the condition for parallelism and the perpendicularity of the line segment. For example, okay, listen. Here is 2 line segments L1 and L2. L1 and L2. Here is x-axis, here is the y-axis. Okay, now listen, L1 and L2 with angles alpha and beta. Okay, If condition for parallelism is very simple, two line segments are parallel, their slope must be equal. That means tan alpha equal to tan beta. That means if tan alpha is related with the line segment L1, therefore we can say that M1 equal to M2. Okay, that is our condition. Remember that if tan alpha equal to tan beta, then we can write M1 equal to M2. Two line segments L1 parallel to L2, then the condition is M1 equal to M2. Two lines are said to be parallel, their slope must be equal. Okay, now we can move to another section, that is called, another one is the condition for two lines are perpendicular. Okay, how to find out the condition for two line segments which are perpendicular? Okay, now listen. Two line segments are said to be perpendicular. That means the line segment form an angle of 90 degree. Okay. If the two line segment L1 and L2, listen. This is our x-axis. This is our y-axis. Okay. Now listen. Two line segments L1 and here is L1. Here is L2. L1 and L2. The angle is 90 degree. Okay. Slope of L1 is M1 and the slope of L2 is M2. Remember that when the two line segment L1 perpendicular to L2, then remember that the condition is very simple. M1 into M2. M1 into M2 equal to -1. That is our condition. Okay, remember that two line segments L1 and L2 are perpendicular. Then we can write M1 into M2 equal to -1. Very, very important. If two line segments are parallel, then slopes M1 equal to M2. If the two line segments are perpendicular, then M1 into M2 equal to -1. It is an important equation. Okay. Now we can move to another section.